Now we're looking at Ohm's law here, so we're going to have to use what we know about equivalent resistance as well as the loop rule and the junction rule also to apply that to the circuit. So we have a 9-volt battery, we have 3 resistors. It's not a simple series or parallel, so if we want the total current, we're going to need the equivalent or total resistance. And then we can sort of transform it into a 1 battery, 1 resistor circuit, which is easy to solve. So, find the equivalent resistance. We don't have a simple series or parallel, but R2 and R3 are in parallel. So REQ, or 1 over REQ for R2 and 3, we can get pretty easily. Which means that REQ, if I take the inverse of both sides, it's 1 over 220 ohms plus 1 over 470 ohms inverse. That's right about 150 ohms. So I can transform this set of resistors into something that looks like that. So 150 ohm resistor in place of those 2, 100 ohm resistor. So REQ is a simple series, so 100 ohms plus 150 ohms. 250 ohms for the whole circuit, which means I can transform the whole circuit into just a battery and a 250 ohm resistor. So by the loop rule, I go plus 9 volts over the battery. To get back to where I started, I must go minus 9 volts over the resistor. And I know the resistance, so that's REQ, because I'm looking at the total. And I'll get then the total current, which is the current through the battery. Right? So this is the current we're interested in, right? Total. So we're looking at delta V, the voltage drop across the thing. The absolute value is the battery voltage. This is the total current. That's the equivalent resistance. Alright, so we know those things. 9 volts is the unknown current times the 250 ohms. Equivalent resistance. So I total is 9 volts over 250 ohms, which is 36 milliamps of current. Now once I know this, I can go and solve the rest of the circuit. The problem is over here, but just for practice, I'll show you the rest of solving the whole circuit. So I'll draw out my chart where I have delta V, I, and R. And I'll look at R1, R2, R3, and the total. I know my resistance is 100 ohms, 220 ohms, 470 ohms. I know now the equivalent resistance is 250 ohms. I know the total current is 36 milliamps. And I know the voltage change across the whole thing has to be negative 9 volts. Okay, so I total is coming through the battery. There's no branches before R1, so the total current has to also be the current through R1. Now I have 2 out of 3 in this column, so I can use Ohm's law. So delta V for R1, the absolute value of delta V is 36 milliamps times 100 ohms. Okay, remember you have to put this in SI units, that has to be 0.036 amps, and then you multiply it by 100 ohms, so that'll give you 3.6 volts. It's a resistor, so it's going to be a drop in voltage, so that's minus 3.6 volts. Okay, now if I use the loop rule, say I'm going to follow the loop here, plus 9 volts, minus 3.6 volts, minus whatever this is, would get me back to where I started, right? So the loop rule will tell me that 9 volts minus 3.6 volts plus delta V across R2 should give me 0. So delta V across R2 should be negative 5.4 volts if I just solve for it there. course, I could also do the loop this way. +9, -3.6, and then going across this resistor. So I have to lose the same 5.4 volts across that one as well to satisfy the loop rule. Now I'm in good shape here with Ohm's law. So absolute value of delta V is IR. I is absolute value of delta V over R. If I apply this to R2, then that's 5.4 volts over 220 ohms. If I apply that to R3, that's 5.4 volts over 470 ohms. So for R2, that means 24.5 milliamps. And for R3, that would be 11.5 milliamps. And let's check the junction rule. So we have current flowing in here and then splitting. So the current through R2 plus the current through R3 should add up to be the current, the total current. So 24.5 plus 11.5 does give us 36 milliamps total. So everything there checks out. Loop rule works, junction rule works, Ohm's law works. So this is the sort of total solution of the circuit. That's every voltage and every current. So that's everything we could possibly want from this circuit.